Hello and welcome to the 6th tutorial in this series. We are going to cover actually blending the diffuse and normals in this tutorial. This is going to get a little bit more advanced as far as the normals go. Diffuse is fairly easy, but the rest is not so much. So we're going to start with going back into our code. And we are going to look and see what we have. So we have our textures, we have our slope mask to do the actual blending, and we have our C albedo, which is our final blend. So I'm going to comment a section. I'm going to call it, can't find the I, diffuse blending, because we're going to be blending more than just the diffuse ultimately. Okay, so let's start by laying this out. We have our base our base color, which is the C albedo. That is defined up here in. Okay, that's normals. Wait. Where's my albedo? So that's defined here. It's a half-3. C albedo is equal to diffuse map.rgb. Diffuse map is the map that's gotten directly from the material editor. It's this one right here. Okay, so basically what we want to do is we want to linearly interpolate using a mask. So basically we want to take our C albedo and we want to lerp it. We want to lerp our base color, so our C albedo, and we want to lerp it with the slope diff. And as a mask, we're going to use our slope mask. Okay, so let's take a look and see what that looks like. Okay, did I actually save the file? Oh, we're still overriding here. So I'm going to actually just comment this part out. Okay. So you'll notice that the diffuse is lerping on top of it. However, we have a little bit of an issue here, and that is that we're getting some funky colors. This is because we need to actually clamp this value beyond the range that we want it to. Let's go to reload again. Oh boy. Looks like I made a, let's see, clamp. No, that looks right. Oh shoot. There we go. Oh man, subtle differences. Okay. Reload shaders. There we go. Okay. Yep, that's what the problem was. All right. Go to here. Where's our mask strength? There it is. All right. Our mask strength is, our contrast is too high. So let's bring that down a little bit. Now we got a bit more moss blending, which is nice. All right. Cool, we got the moss growing up in here. It's looking pretty good. Okay, so the next thing we need to do is we need to actually blend the normals. This is going to be a little bit more, well, okay, a lot more complicated. We're actually going to need to blend these in world space. So I believe the normal map gets converted to world space down here, or maybe it's already converted in the normals section. So here's smoothness, here's normals. Okay, so when does it get converted into world space? Here it is. Attributes normal world equals normalize attributes.normal world minus normalize in view times tc times normal view dependency. Oh, that's leaves. Okay, so it doesn't get world space put into world space until later. Okay, that's fine. Okay, so now we're going to do our normals blending. This one's quite a bit trickier. So we have our V normal, or our pixel normal rather, our P normal tangent space, which is our base normal. So that's going to be called V normal TS. So this is basically our base normal. We're going to need to do the same thing we did before, where we're going to lerp it. So the V normal tangent space. We're going to run a quick test, and I'm going to make sure this is the correct thing to override. So let's just give this a value of, I'm trying to rush too much, half 3. There we go. Okay. Alright, so it looks like that didn't affect anything. So that's not what we want to be adjusting then. Or we're doing it in the wrong order, which is also possible. You may need to actually do the normal map blending in the actual attribs.world normal, which means that we already have to work in world space. So that means that the attribs.normal, which should be attribs.world normal, I think it's world normal. Normal world. Oops. Okay. Okay. That should be the correct one. Yep. Okay, that overrode the normal, which is exactly what we wanted. Okay. Let's go back to our code. Now we know what we need to actually work with. So we're actually going to do a lerp. So equals, and we're going to take our base normal map, and we have to convert our base normal map that comes out of this function, because it gets the normal map gets run through all of this stuff, right? So depending on what happens here, we have a base v normal, and then the get normal map here. If not grass, if normal map, which means that there's a normal map in there, the v normal tangent space will get the normal map, and then this gets edited as it goes down this list, including adding detail mapping if there's a detail map, billboard, changing that. So there's all kinds of stuff that we need to keep in mind for that. However, for down here, we will need to take that original normal map, and we will need to change it. So we need to get the v normal tangent space, like I was doing before, and we're going to need to convert that. So we're going to define a half 3, and we're going to call it v normal world space is equal to, I believe we need to multiply, and we're going to multiply this by the m tangent to world space matrix. And then we're going to wrap this in a saturate function. Or, sorry, not a saturate function, a normalize function. Okay. So we have our normalize, our multiply v normal tangent space by m tangent to world space. This converts our v normal to our normal tangent space to world space, and then we need our slope normal here to be converted. So we're going to half 3. This would be our slope normal world space is equal to normalize multiply our slope norm by m tangent to world space. Alright, so now we can lerp those together. And we're going to lerp our v normal world space with our slope norm world space using the slope mask as our mask. And I'm going to just double check this. I'm actually going to get rid of that so it's consistent. Okay, let's save it. And I believe normalize is a default function. I may have I don't think I wrote that specifically for this. So let's reload shaders. Okay. We look good. Pretty sure that works. So you can see this is working just fine. Let's look at, oh, what am I doing here? Okay. Yep. Looks like we're getting the correct normals. Let's check if they're being shaded correctly. Let's move the sunlight. Environment editor. Let's just change the sun direction. Yep. Normals are being lit correctly. Cool. Okay, so you have just made a pretty nice looking effect. Everything is blended well. In a future set of tutorials, I'm probably going to add to this one, but we'll need to cover adding something like parallax occlusion mapping or offset bump mapping to this shader, which is pretty expensive, but we can make it work. There is a way to cheapen it, but we would need to add data to the base struct for the pixel shader, and that's like add another attribute, and that's kind of intense thing to do. So I will cover that later and maybe some other effect, but we will I will show the brute force way of doing it, and then maybe you can come up with your own version. What I would like to see, and something that I have already done actually with this slope effect, is I've added a second layer to my SlopeBlend effect in my shader. So what I would like to see you do, if you're following this tutorial, is I would like to see you do this and then make improvements on it and show it, or even add extra layers, or maybe try and add the parallax occlusion mapping or the offset bump mapping yourself. It's up to you. You can do it however you want. I'm going to just show in the next video some additional things that you can do to kind of push this feature just a little bit further. Things like normal map overlaying and some more advanced things like maybe you want to change the way that the mask power works. But yeah, so that is the SlopeBlend effect, including the part where we blend everything. So I'm glad that you went on this journey with me. I made quite a few mistakes along the way, but that's part of the fun too. So thank you for watching. The next series should be pretty cool.